Shane O'Mara, In Praise of Walking, the new science of how we walk and why it's good for us. Narrated by Karen Cass and Marston York.
What defines us as humans? Our opposable thumbs? Our large brains? Our language skills? Those may all play a part, but there's one more factor that's often overlooked: our ability to walk. The way humans walk, upright on two legs, is unique to us as a species. It's a big part of who we are. These days, however, we seem to be walking less and less. Instead, we use cars to shuttle ourselves around, from the bed to the office to the sofa. These blinks will explain why walking less is a serious mistake, one that can have negative effects on both our physical and mental health. The blinks also highlight some of the many ways you can benefit from standing up, leaving the house, and taking a stroll.
Blink 1 of 6.
In these blinks, we're going to be talking about how humans walk. But first, let's consider a very different creature, the humble sea squirt. In its early stages of development, the sea squirt darts around in rock pools in search of food. To facilitate this movement, the young sea squirt develops one eye, a brain, and a spinal cord. But then one day, the sea squirt undergoes a pretty major transition. It finds a rock, attaches itself to it, and never moves again. Stuck in place, it then eats its brain, eye, and spinal cord. It just doesn't need them anymore. Why are we telling you this? Well, the lesson the sea squirt teaches us is this: if you don't move around, you might as well eat your brain. Literally.
The key message here is, moving around might seem simple, but it requires brain power.
Okay, sure, but humans aren't quite the same as sea squirts, right? Actually, we might be a little closer than you'd imagine. Developmental biologists recently compared the genes of two seemingly different species, the little skate, a type of fish, and the mouse. And it turns out they share many genes related to movement. These shared genes determine their spinal cords, the placement of their limbs or fins, and the nearby muscles and nerves. This research shows that genes relating to walking stretch so far back in evolutionary history that they mostly developed underwater. However, although we share so much with our ancestors, human walking is unique. Even our closest relatives, apes, generally use all four limbs. So why did we evolve to be upright? Well, our method of walking on two legs is more efficient. We can cover greater distances and carry stuff as we go, whether it's children, weapons, or food. Yet, as efficient as it might be, walking on two legs is hard. When they're learning, toddlers take an average of 2,368 steps and 17 falls per hour. And robots have yet to fully excel at human-style walking. We have our brains to thank for mastering this complex task. One thing the brain is particularly good at is staying balanced. It does this via inertial guidance, which means it's continuously calculating to calibrate our position. Trace the line from the corner of your eye to your ear canal. Your brain will always try to keep this line parallel with the ground. Not every aspect of walking is controlled by the brain, though. The spinal cord handles the central pattern generators that control the rhythmic patterns we need for breathing, the beating of the heart, and walking. The spinal cord, you'll recall, is another thing the adult sea squirt eats once it's secured to its rock. We humans, though, make the most of our ability to move around. You could say walking rocks.
Blink 2 of 6.
It's not just the mechanics of walking that requires brain power. There's also the question of how we actually know where to go. Put yourself in the author's shoes. It's a good few years ago, before the age of smartphones. You have to walk from North London, Highgate to be precise, all the way back to your home in Streatham, which is a long way south. You don't have a map. How do you do it? Well, essentially, you channel your inner homing pigeon. Dead reckoning, otherwise known as path integration, is our innate ability to move in the right general direction toward a destination. But as for how that works, scientists are only just coming to grips with it.
The key message here is scientists are slowly working out how our sense of direction works.
Strolling right through the heart of London, across the River Thames and down through the south, the author managed to find his way home, even though he was going through areas he didn't know. He was able to do this because finding our way around isn't wholly dependent on visual cues. Several studies have proven that our spatial sense is not greatly affected by our ability to see. In tests measuring a sense of direction, blindfolded people and people with visual impairments performed similarly to those with normal sight. The neuroscientist John O'Keefe has made some pioneering discoveries regarding how the brain determines where we are. He discovered that when rats wander to a place they know, particular cells around the brain's hippocampus light up. Different cells light up when they move somewhere else. These are known as place cells. They tell us where we are. Humans have them too, and they work most effectively when we walk. Further research has revealed even more fascinating types of cells in the brain that help us get around. Head direction cells are essentially an inner compass, indicating our orientation. There are also cells that respond to nearby objects. The author himself has worked on perimeter cells, which respond to the boundaries that surround us. All in all, the brain more or less has its own GPS network, constantly updating itself as we walk around.
Blink 3 of 6.
Say you take a trip to Italy and you're sitting outside one evening. You may well see locals taking what they call a passeggiata, a stroll through the neighbourhood, where they chat with friends and neighbours. It's a wonderfully sociable and calm end to the day. Given our boxed-in, busy daily lives, it's especially important to have a moment of calm like that as part of your daily routine. But, unfortunately, our cities don't make it easy for us. Over half the global population lives in cities and urban areas, and that will probably rise to 80 or 90% by 2050. Urban planners have tended to respond to this by prioritising traffic flow through cities and paying little heed to walking. This is the opposite of what we really need.
The key message here is it's more important than ever that our cities are walkable.
What makes a city walkable? First off, there need to be amenities like shops and schools within walking distance of where people live. What's more, the quality of walks around the city must be high. That means comfortable, safe, and interesting. The streets should almost be like living rooms, pleasingly decorated. And of course, there needs to be plenty of green space. Think Hyde Park in London, Central Park in New York, or Cubbon Park in Bangalore. Last but not least, a walkable city should factor in the ageing population. Road crossings in particular should be designed so that older people can get around with ease. This might all sound like a nice-to-have rather than a true priority, but the benefits of a walkable city are huge. Easy access to shops and offices leads to more economic activity. So does the act of walking itself. Some economists have shown there's a negative correlation between how much time you spend in a car and your economic productivity. With sensible city planning that factors in the benefits of walking, the passeggiata doesn't have to be an exclusively Italian phenomenon. The author encourages city planners to use the acronym EASE. Cities should be easy to walk, accessible, safe, and enjoyable for everyone. In fact, the author suggests that urban design is being done by the wrong people. Instead of city planners and architects, he would like to see psychologists and neuroscientists put in charge. They're the ones who really know how to make a city walkable.
Blink 4 of 6.
Think about how you feel after a long day at the office, or after being stuck at home all day. Most likely, you feel a little grumpy, and there's scientific evidence to back this up. Your personality actually changes when you don't move around. Less physical activity leads to lower levels of extroversion, openness, and agreeableness. So it's not just change, it's change for the worse. Precisely what is it about inactivity that causes this change? The science isn't clear, but the author suggests there's one fix that's very likely to reverse this trend with ease. Yep, you've guessed it. Walking.
The key message here is walking really can be the best medicine.
It was the ancient physician Hippocrates who said walking was the best medicine. Perhaps he'd have some stern words today for those of us who spend all day cooped up at home or in our offices. A US study found that people spent an average of 87% of their time in those sorts of artificial environments. It's difficult to measure, but research does indicate that spending time walking, especially outdoors, is good for feelings of well-being. According to one study, future cases of depression could be lowered by around 12% if everyone spent just 1 hour a week doing physical activity. Another UK study showed that visiting natural environments, like the countryside or green spaces, really does lead to people feeling mentally restored. Walking and other types of exercise have positive effects on brain function too. The act of regular walking plays a part in the production of new brain cells that help with memory and learning. Plus, there's the effect that walking has on our muscles, a relationship that can be summed up with the phrase, use it or lose it. The body simply doesn't bother maintaining muscles that don't get regular use. Any exercise is good then, but in terms of well-being, exercise in the open air really does seem to be best. A study in Ottawa, Canada, asked people to walk the same distance via 2 different routes. Some walked by the riverside, while the others walked through a tunnel. After the walk, they were asked to rate their moods. Those who had walked outside scored notably higher. So, whether you want to build new brain cells, stimulate your muscles, or just feel a bit better, the solution is the same. Go for a walk outdoors, the greener the better.
Blink 5 of 6.
In 1843, the Irish mathematician Sir William Rowan Hamilton was working in the field of complex numbers, but he was stuck. Fortunately, however, Hamilton had the habit of taking long 2-hour walks every day, strolling to work in the centre of Dublin. And it was on one of these walks that inspiration struck. I squared equals j squared equals k squared equals ijk equals -1. That was it, the breakthrough he needed. He whipped out his penknife and carved the formula into the bridge where he was standing. It was a moment of inspiration. The formula is still fundamental to the study of complex numbers in 3-dimensional space. These days, mathematicians hold a Hamilton Walk on October the 16th every year to commemorate his breakthrough. And it's all because of walking.
The key message here is walking boosts creativity.
Walking has inspired all sorts of creativity, not just mathematical breakthroughs. The moment my legs begin to move, my thoughts begin to flow, said Henry David Thoreau. William Wordsworth's poem Tintern Abbey was written during a long walk as well. Only thoughts reached by walking have value, was how Friedrich Nietzsche put it. But why does walking have this effect? The answer, as you might have guessed, lies in your brain. Your brain has 2 modes, an active mode and a default mode. When your brain is in active mode, it's focusing on a task, doing stuff in detail, counting something, for example. In default mode, your mind is free to wander, exploring and processing memories. That's not as frivolous as it sounds. It's vital for keeping your brain in order and your thinking sharp. Evidence suggests that creativity occurs when these 2 modes of thinking occur simultaneously. And walking is a great way to encourage the brain to do exactly that. Walking, or more specifically, spatial navigation, stimulates the part of the brain around the hippocampus, which is also the part of the brain that's active in memory. Walking might not help with uncreative problems like mathematical calculations, but for creative problem solving, like coming up with a novel mathematical formula, walking can help greatly. The author calls it active idleness, letting your mind wander freely, yet still retaining a sense of focus. You've probably heard people say you should sleep on a difficult question, but why not also try walking on it? Next time you have a challenging problem to solve at work, give it a go.
Blink 6 of 6.
Not all walking is a solitary activity in which your mind can wander. In fact, walking is deeply, fundamentally social. Mark Twain knew it. The supreme pleasure of walking, he wrote, comes from the talk. There's science to back this up too. One study found that elderly people who walked for around 150 minutes each week were more socially active. They also had higher levels of well-being compared to elderly people who walked less. Walking is also a crucial step in young children's social development. Once they can walk, they both play and vocalize a lot more.
The key message here is, at its heart, walking is social.
Even some solo walks have a social aspect. Think of pilgrimages. People may undertake them alone, but there's still a deeper sense of solidarity there. They unite the walker with others who share the same faith or cause. Even a solo city walk, in fact, is defined by the people and crowds you encounter along the way. But walking together with others is perhaps especially important, and also scientifically interesting. Have you ever noticed how you and your fellow walkers tend to synchronize your steps? This is totally normal in group